Okay, today I'm going to try something a little bit different. This is the Pearson Edexcel linear AS level in physics. So what I'm trying to do is to go through this paper using the examiner's report instead of writing the answers out on a blank paper. It's really because of a shortage of time. And this June 2017 paper, I've given my students to use as practice because the AS Core 2, which has this technical number, which I don't use, for the linear, is on Wednesday. So next Wednesday is their exam. And I thought it takes much longer to actually go through the questions. And I thought, let's look at the examiner's report and see what we can learn from what they give us. And they do give some exemplar material and some students' answers, so it's worth looking at. Okay, so if you're my students and you're preparing for this exam on Wednesday, use this as with your paper in front of you. So the best thing to do is to have your AS Core linear paper in front of you so you can look at what the questions are, because they don't always show you the questions. So first of all, the multiple choice is quite interesting, the way they go through the multiple choice. Question 1, they're telling you that the percentage of people that got that each question right. So in question 1, only 56% of the students got the answer correct. And question 1 was to do with a mass again on a spring. So as you add mass on a spring, of course, it's going to extend. And the question wanted to know what is the correct expression for the work done in extending the spring. And the examiner's comment is that the work done is found from the area under the graph, which is correct. And the common incorrect response showed that people forgot, a lot of students put A down because they forgot that the area under the graph is a triangle, so it's half base times height, and they forgot to divide the answer by 2. Okay? The other thing you need to realize in this question is because it's a mass against extension, that you also need to change the mass into weight. So to get the expression right, you've got to change mass into newtons. Okay? Question 2 then was to do with the speed of waves on a string. Yeah, so the equation is given in the answers, and it shows that many students, all sorts of incorrect answers. So the answer must be D if A, B, and C are incorrect. And you've got to use y equals mx plus c to find what you should put on the y-axis and what you should put on the x-axis to get a straight line graph. So they want to see if you know how to get a straight line graph. So 59% of the people got it right. That means 41% got it wrong. And to get it right, you need to rearrange the equation, to get it into the y equals mx plus c. Now, because the equation is v equals the square root of tension over mu, where mu is the mass per unit length of the string, then what you need to do is to realize that if you square both sides, it's the easiest. V squared equals t over mu, yeah? So if you plot v squared against t, then the gradient will be equal to 1 over mu, because mu is a constant. So you could do v squared over t, but v squared over t is not one of the responses there, but obviously if v squared is proportional to t, then that v must be proportional to the square root of t, and again, that would be a valid straight line graph, okay? In the diffraction grating question in number 3, you need to use the equation. 72% got it right, so you need to use the equation n lambda equals d sine theta. And the best thing I can say is change it round to n lambda over d equals sine theta. I'm going to write it here. So that equals sine theta. Because the question is asking you, how can you change, what do you need to change in terms of the number of slits per meter, which is 1 over d. So now I've put 1 over d on the other side. And the other thing is what changes to the wavelength will lead to a bigger separation between the right fringes. And of course that means it's proportional to theta, which is proportional to sine theta. So if you increase lambda, that will be one way. And if you increase 1 over d, so remember this d is on the bottom, so if you increase 1 over d, then that will also increase sine theta, okay? Because they want the number of slits per millimeter, which is 1 over d, whereas d is a distance between them. So that's how you do it. This one better is in terms of 72% getting it right. In question 4, it's to do with phase difference, and 61% got it right. Yeah, and the phase difference between the two graphs, you just got to know how to do it. So they've given you a time, t, and so t over period will be equal to the phase difference divided by 2 pi, because these ratios must be the same. Because what t is to 2 pi, a full period, then the phase difference in time will be equal to that. So they want you to work out the phase difference. So if you do that, you'll see that you can put phase difference on the left-hand side, make it the subject of the equation, and you'll get t times 2 pi over t, which gives you the answer A. Okay? So it's quite useful to see the amount of people getting each question right or wrong. Question 5 is about energy levels and the energy levels in atoms. So it's the quantum thing. So delta E, you've got to work out which delta E transition is equal to the energy of the photon. So delta E must be equal to the HF, which is 3.2 electron volts, and only one transition, which is from the ground state, to level 2, gives you the right answer. And 76% of students got it right, so the answer is B. Some people got A. I don't know why they got A. I think they were looking at the energy of level A rather than the energy difference between two levels. Okay? So the answer is B. All right, and then the next question, I actually made a mistake myself when I first looked at it. If you read the question, so this one only 56%, got it right, and that's the equal lowest in terms of the multiple choice questions. So the incorrect response, it says, showed that Candace appreciated that this was linked to a factor of 4, but they got it the wrong way round, okay? They knew that by doubling the radius, that because area is radius squared, they looked at intensity rather than power, okay? So I'm not going to go through it now because it's a little bit, needs a bit more space than the space provided, but the answer is D, So the power, because I think that in the same conditions, the rate at which energy is transferred to the solar cell of radius 2r, only A changes. And we want to know, well, if A changes by a factor of 4, that means if the intensity, the same conditions, means that I, the intensity, is constant. So if the area goes down by a factor of 4. Yeah, so 4 times down then means power has to go up by a factor of 4 times to keep I constant. Okay, question 7 is about coherent waves. So it says that light, for 2 waves of light to be coherent, this is just a knowledge question, they must originate from the same source, and 86% of you got it right, or 86% of people took it in 2017 got it right, which is one of the second highest, I think, for the multiple choice. So that's good. Yeah. I'm not going to go through that. So it's just basically you need to split a source of light into 2, because if you use 2 different sources of light, they're never coherent. They are basically unique random emissions of, so if you're talking about light, random emissions of photons, so they never are coherent with each other. Okay, it's not like a constant frequency wave that you might imagine. And then the last bit is ultrasound scanning, and the question wants to know that the reason why ultrasound waves are transmitted in pulses. Yes, so that's again a very well answered question. 90% got it right, and the reason is the pulses have to be short enough so that they return before the next pulse is sent out. Okay, and that's a common question. So that's the multiple choice feedback. Question 9, you'll see that this will be it will be easier to go through the structured questions, because the question is in the examiner's report. It says, in the 1920s, Louis de Broglie proposed that electrons could behave as waves, which we know, yeah? And they just want you to calculate the wavelength. So this is a student's work, and the student got it full marks. So lambda is h over p, where p is mv. So you multiply mass of an electron by the velocity, which is given to you in the question. Yeah. And once you do that, you can work out that it's 3.3 times 10 to the minus 11. So this is how I like students to write out their answers. So I like showing you this because it shows how a real student under exam pressure can give their answers, and he's put the answer, or she, to 2 significant figures, which is correct. Yeah, because the data provided is given to 2 significant figures here. And this mass of the electron is provided in the data sheet. Because the mass of the electron obviously is known to 3 significant figures, but because the speed is the only piece of data we've been given in the question, then we should stick to 2 significant figures for the final answer. Okay? So this is very simple. If you get a de Broglie equation, you should be guaranteed the marks. And here's I like this part of it as well. So it's giving you examiner's tip. In calculations where the mass of an electron is required, don't forget that this is given in the list of data at the back of the exam paper. So get used to it. And here it's just got a comment that the student got full marks and why. Here's one who didn't get full marks. They know that the equation is this. They've got lambda backwards. Okay, so lambda is this way, just for general knowledge. They divided h by velocity. They didn't know where to get what p was, it looks like. So this student, it says, it's a common example of an incorrect example. It doesn't say how many marks they get. As without a value for mass, 0 marks could be scored. Okay? Because obviously they don't get the mark for working out the momentum, which would get you 1 mark, and then they're not dividing by momentum either, so they don't get any marks. Just want to read the examiner's tip. There is an expectation that some constants are used even when not specified in the question. Yeah, so you need to know, obviously, you've got to problem solve yourself. They're not going to give you all of the data that you require in the questions. Question 10a, it's about polarization, and polarization using a transmitter and a receiver for using microwaves. Okay, so I think you'll have to look at your question for this. Okay, but the describe what is heard as the receiver is rotated. So initially, the receiver is in line, is set up to pick up the polarized form of microwaves which are emitted by the transmitter. Yeah, so the transmitter is giving out the polarized waves, and then they rotate the receiver through 180 degrees. So as they rotate it, when it reaches 90 degrees, the receiver will no longer be able to pick up the plane polarized microwaves. And then when it goes back towards 180 degrees, it will go back to maximum intensity. So it goes from maximum intensity to zero intensity, back up to maximum intensity. So it kind of should be like a sine wave. So this student's written, initially the audible output should be at its maximum, at its highest, as the polarized electromagnetic microwaves are of the same orientation as the receiver, or the receiver is in the same orientation as the microwave that are emitted. As it rotates, it will get quieter till it is 90 degrees to the receiver, to the transmitter. As the wave phase plane is 90 degrees to the receiver. Okay, the wave plane of the polarized waves, he means, or she means. So as let me read that again. As the wave plane is 90 degrees to the receiver, there is no sound. Well, that's correct. Okay, the answer is correct. Then as it continues to rotate from 90 degrees back to 180 degrees, the sound should get louder and be, I can't read this, it changes when it's 180 degrees again. So this is definitely worth 2 marks. It's only 2 marks, so the response gets both marks. Okay? So the examiner's tip here is make sure you answer a question fully, yeah? In this case, the candidate would not have gained full marks if they had not correctly referred to both 90 degrees situation and 180. So this is maximum at 180 because they're back in alignment, the polarized source and the receiver, okay? And this one will be minimum or 0 in terms of the audio output. And the reason there's a sound output is because the receiver is connected to a speaker. Okay, you'll have to look at the question to make sure you understand what they're talking about, and you can stop this and read what the examiner's written here to help you. So this is a good, quick way of going through a paper. Okay, question 10b then says explain why points of maximum and minima are detected. Okay, so I think this is like a 2-slit interference pattern that's produced rather than a diffraction grating. So you got to transmit. So they're still using the same microwaves. Okay, so it's about the interference of 2 waves from 2 gaps in the context of the microwave transmitter and receiver. Candidates were expected to translate the physics of interference into this context. Okay, so it says many candidates referred to troughs and peaks, which is not the terminology that is generally accepted at A level. Okay, so let's see how many marks this student got. This is a good 4-mark answer from a student. When the electromagnetic wave passes through the gaps in the diffraction in the metal plates, there's basically 2 metal plates, because obviously they'll be reflected, microwaves are reflected by metal plates. Diffraction occurs, causing the spreading out of the two coherent secondary waves. You could add in coherent there. When these secondary waves interfere, as in superpose, they meet. When they meet in phase, when they interfere and they're in phase, they superpose constructively, resulting in the formation of something with maximum intensity. I can't read that word. When they interfere in antiphase form, again I can't read this word, they superpose destructively. So he's mentioned constructive interference, destructive interference, and interference being superposition of waves, where the resultant vector sum of their displacement is 0. I like that. Yes, he realized that displacement is a vector, forming areas where there is minimum intensity. Yes? Now, it's right to say minimum intensity because it won't always be 0 if one of the waves is, if one of the sources of the separated waves, as in split into two sources, is closer, then the amplitude of the one that's closer will be slightly more than the amplitude of the one that's further apart. So this student gets 4 marks. And here the examiner's tip again is useful. Remember that if two waves are out of phase, they are not necessarily in antiphase. But for complete destructive interference, and therefore for 0 points of intensity, the two waves need to be in antiphase. So antiphase is when they're exactly the opposite in their cycle. Like that. Okay? Alright, so that's the only time you're going to get complete cancellation, and if the amplitudes are equal. Hope that makes sense. Okay, question 11 is about ray diagrams, and it's a diverging lens. So the diagram shows 3 parallel rays of light incident on a diverging lens. So they're coming in from this direction, parallel to each other, and then they refract as they go through the edges of the diverging lens. So the one in the middle is the only one that doesn't refract, as in change direction, doesn't deviate. So they want you to then, it says the diagram is drawn to actual size, so it's drawn to scale. They want you to add the lines, that the dotted lines that the student's drawn, to determine the focal length of the lens. So basically, you redraw the lines going backwards. I'm going to now draw them in green, to see where the ones that go and get divergent, where they cross, and that will be the focal length. You then have to measure it from the center of the lens, and that, because it's drawn to scale, will give you the focal length. Okay? This response scored both marks. The 2 rays are drawn back to the principal axis. So the principal axis is the middle line. The mark is given for either dotted or solid lines, but 2 lines must be drawn and extrapolated. Yes, that means goes beyond the F point. Okay, and you should, remember, use a ruler to draw any ray diagram. So this is from the examiner. And then here it says the focal length is measured to within the correct range for the second mark. So if you're outside their accepted values, you didn't do it accurately, you'll lose one of the marks. Question 11a, it wants you to calculate the power of the eye. They've given an image of an eye and the distance from the object, which is u, and the distance to the other side of the lens where it focuses. I'm just bringing it up on the screen. So focus on the back of the retina. So V is a distance from the front of the lens to the retina, back of the retina. They've given you the value for F and V and U, and they want you to calculate the power. So this student has rightly put the power is 1 over the focal length, which is equal to 1 over U plus 1 over F. So the power is, you can miss out one step by doing that. You can get rid of this line and go straight to the power, which is what they want you to do. So if you can do that mathematically, you will see what the answer is. Okay? All 3 marks were awarded for this student's answer. So I'm going to let you have a look at this. Yeah, what they've written. I don't think there's anything else I need to add. You can stop the video and have a look at the examiner's comments. Okay? Yeah, so don't forget to convert to SI units. Oh, the data could have been given in centimeters, and to get the power, you need to change it into meters. Good point. Okay, so the examiner's report is worth looking at as well. All right, so question 11C, if I quickly have a look to remind myself, this is a person who is long-sighted, yeah, cannot see clearly because the objects are focused behind the retina, or try to be. So the rays of light coming in from the same point as in 11B, yeah, same distance, converge, but they can't converge on the retina, so I suppose you get a blurry image, which is my problem. So for things coming from a distance of reading like 25 centimeters away, which is what's called our near point distance, this may be corrected, it says, for the person with this eye problem by adding another converging lens, and they're saying, state how adding another converging lens would enable the light rays from the object 25 centimeters in front of the eye to converge on the retina. Okay, well, this student has rightly said that the power is increased by adding a second lens, one being your eye's converging lens, by an additional diverging lens he's put, yeah, would make the power of the eye stronger. Converging, oh, this is converging. So be careful the way you're writing it. I didn't see this is the C and then on, and it looks a bit like, if you put a dot there, it could be misread as diverging, okay? Would make the power of the eye stronger, as now there are 2 lenses and helping to focus the light from 25 centimeters on the back of the retina, okay? So it make the light rays converge more, and that's what increased power means, meaning it would converge at closer, a smaller focal point, means a closer distance. This candidate, it says, clearly understands that the power would increase. So that's really what you've got to show, is that the power would increase, and that's all you need to say, because only 1 mark answer. Question 12A is then about a mirage that forms on a road, and they're saying initially, what is meant by a virtual image? Well, I always like to say a virtual image is one that cannot be projected onto a screen, okay? And a real image is one that can be, okay? So that's the easiest way of remembering it. Make sure you understand and can describe the difference between a real and virtual image, okay? So that's basically it. You can just use this definition for both, okay, if it's a 1 marker. And state what is meant by a virtual image, yeah? So virtual image, this is an incorrect answer, okay? It's not real, he's put. It's a reflection. So obviously this is he's just guessing, I think, okay? So he has not learnt a definition for a virtual image. Okay, this is the same question. So one correct answer or one incorrect answer. Okay, 12 part B, the examiner has written a whole load here, which I'm not going to read through. I want to try to finish this video as soon as possible. You can read it. It's useful for you to go through. Okay, and this is a 6-mark question. And the question is the second part of the mirage question. It says they're giving you information about the 3 layers of air, the hottest layer being at the bottom, yeah, and how the light refracts or reflects off each surface depending on the law of refraction. Okay, so you're going to have to use this equation at one stage. Okay, it says use the information provided in the question as to whether the observer sees a mirage in the position below. Okay, and 6 marks. So what you've got to do, if I remember correctly, is, which question are we looking at? 12. So for this question, you want to make the following points: that light will be refracted at the first boundary. So it's basically 3 layers of air. Do look at it, and you will see. Okay, this question. This student has written a near perfect answer, not a perfect answer. So he got 5 out of 6. Okay, missing out on a marking point, number 6. So at the first boundary, the light does refract because the angle that they're given you is less than the critical angle. So, and then you can then work out the angle of refraction by using this equation that I've just put the yellow box round. You put the numbers in, and you'll find, as this student has correctly, that the refracted angle is then very close to 90 degrees. So at the second boundary, when it's hitting the hottest layer near the road, the angle is now theta 2, I'm going to change the color, is now greater than the critical angle, which is this. And this is given to you in the question. So the second layer that they give you, from layer 2 to layer 3, it then creates total internal reflection. Yeah, so this creates total internal reflection, but only at the second boundary, not at the first boundary. The first boundary changes the angle such that theta 2 is greater than the critical angle. So the second boundary, total internal reflection occurs. So basically the mark scheme is looking for light is refracted as it passes from medium 1 into medium 2, but the angle of refraction can be calculated. So this is the second mark, refraction is the first mark, and then it goes on to saying that you can use that equation to work out theta 2, so that's 3 marks, yeah, as well as mentioning refraction. So it says the calculation above shows that the light traveling from layer 1 to layer 2, striking at an angle of 89.59 degrees, will be refracted at an angle calculated above 89.8 degrees. So refraction will get 1 mark. Okay. Then at the next boundary, you say this time, when it reaches the boundary of layer 2 to layer 3, its angle of incidence is now equal to its angle of refraction. Well, it means it's going to, he's mentioning that he understands how the alternate angles work. You don't actually need to say that. All you need to say is this angle is greater than the critical angle for the second boundary because they've given that to you in the question. Yes? Therefore, at the second boundary, it doesn't refract. It gets totally internally reflected. Okay? So that's what you've got to do. So this is greater than the critical angle, so it's totally internally reflected within layer 2, so it does not reach the road surface. So this is the final part where you didn't get the marks. The observer does not see the mirage. Well, that's wrong. Okay? That's why he's got 5 marks. For the final mark, this is why the observer sees the mirage, because he sees a reflected light at a certain angle as he's approaching the mirage from a certain distance away. He will see the light bouncing off the hot layer of air and coming towards him at that angle. So he will see the mirage. Okay? So it appears to be coming and creates a virtual image. Obviously, it's not a real thing. Okay? So here again, the examiner has given you some comments, which you can stop the video at and read. Okay? So this is an alternative answer, and this, I think, is the perfect answer. This answer, it says, scored 6 marks. For the sake of time, I'm not going to go through it, but you can read this and see how they write a good answer. Okay? The other thing you can do is write in bullet points, so you can see the student has done the same kind of calculation. Yeah? And presumably he's then made the final marking point, which is to say that the total internal reflection of the hot layer of air close to the road causes what we call a mirage. Okay? So this is question 12, 7 marks. The perfect answer. Have a read through it. And then question 13 is a new question. And question 13, if you've got the exam in front of you, is about an experiment to determine the viscosity of glycerol. Yeah, so the student determines the terminal velocity by dropping a steel sphere, a ball bearing, through the glycerol, and they're given the equation to be able to calculate the terminal velocity. Yeah, so they put all of the data that you need, and they want you to derive how they got that equation, and they've given you this as your starting point. So at terminal velocity, they're giving you an equation which ends up looking like this, and you've got to show how to get from there to there. And this student gets all 3 marks. The writing is a little bit, so the weight of the solid sphere is the volume times the density times gravity. Yeah, the density of the sphere, that's what that is, the data. And obviously the drag, change color, is equal to Stokes' law, which is this in yellow. And then the upthrust is the weight of fluid displaced, which is the volume of the sphere times the density of the liquid multiplied by g. So you put those values in, and then you do your algebra, yeah, which is try to get this into this format. And the student has managed to do that. So algebra gets you 3 marks, okay? Now what are the comments here? All 3 marks achieved on the first line. The terms given by the candidate are written in the same order as shown in the question, so they are assuming that the candidate knows which term relates to weight, drag, and upthrust. Okay? But you can see the way I've color-coded it, that would be a better way of making sure that another examiner might question whether you have linked the each bit correctly. Okay, so my color coding should help you. And it says, credit is not usually given to a candidate who has clearly worked backwards from the final equation. Well, I don't know if he has. They're assuming that, okay? In other words, they're saying he's worked out how to get to that. Well, that is the mathematical skill. I don't agree with that examiner's tip, but usually that's what they're saying. Question B, then, the same question continues. The student drops a steel sphere of a specific radius into a cylinder of glycerol that we've just been talking about. And the sphere reaches terminal velocity and takes this long to fall once it's reached terminal velocity. Okay, they want you to calculate the viscosity using the same equation which you had to derive and that was given before. So you first find the terminal velocity by using this, and then obviously you need to work out the volume of the steel sphere, 4/3 pi r cubed. Looks like this student has done it right. He's changed 4 millimeters by putting it 10 to the minus 3 before he cubes it. So he's put all the values in, and he's got the correct units as well, which I think is one of the marks. So looks like he's got all 4 marks. Okay, so you can stop the video and have a look at what the examiner's written here and what the examiner has given to you as a tip. I hope you're finding this useful. I don't have time to write out all the answers myself, but I thought it would be nice for you to see some of these written responses. B part 1, this is another solution, and this student just didn't know the units and tried to work them out using SI units and just got it slightly wrong. Good attempt. Yeah, so everything else numerically was correct, but for something to be correct, you also need the correct units. So that's all. So it says, if you cannot remember the unit, a useful skill is to substitute into the equation and work out the base units, okay? So the alternative, if it was base units, would be kilograms, meters to the minus 1, seconds to the minus 1, okay? So these are alternative units that you could use. And this is another answer. Again, looks like he gets 3 marks, incorrect units. So you do need to know your units, or you need to know how to derive them. Question 13b, it's a continuation. There are 2 cylinders available for the student to use. Remember, the ball is 4 millimeters diameter. One cylinder has diameter of 1.5 centimeters. The other has diameter of 5 centimeters. You've got to state and justify which cylinder the student should use in order to gain the most accurate value for the viscosity of the glycerol. So remember, this is Stokes' law, so it's to do with Stokes' law. And you want laminar flow. The 5 centimeter cylinder is better, as the wider tube will allow the ball to fully experience Stokes' law, apostrophe, as it has a higher chance of laminar flow. Okay, so he's mentioned that it's to do with laminar flow. This was a rare correct answer. Yeah, so if the tube that is falling through is narrower, that increases the chances of turbulence. That's how I would say. Yeah, so there's a chance of turbulence, and for Stokes' law to apply, you want it to be laminar flow. Okay, so to achieve laminar flow, you want the ball bearing to be small, you want it to be spherical, and you want it to be not moving so fast that it creates turbulence. Now, I'm not saying that it will create turbulence, but the better one would always be the wider one, because you're further from the friction that the side of the cylinder will cause against the fluid. Okay, I think that's a difficult question. So this is another answer, so you can read through that and see what the examiner says about this answer, which I believe no marks are scored, as the reason is incorrect. Okay, and here's another one. Again, you can have a look at what the examiner's saying, only because of time. Stop the video and have a look. Question 14 then is about the speed of sound. So this is a core practical, And this is from the GCSE version to the A-level version. This is a student, explain how a sound wave travels through air. So they want you to explain longitudinal waves, what they are. And this is an example of students scoring both marks. Okay, so you need to know what a longitudinal wave is. It's a nice, easy 2 marks if you've done your revision. Okay, and then it says explain. This is another example, and this one was awarded 1 mark. So again, you should have a look and see why does this answer get 1 mark and the first one got 2 marks. Okay. And then part B, part 1, 14B, part 1, which is the next question. They're giving you some data that the student had collected for 2 different days. And basically what the method was banging 2 blocks of wood together and working out the time for the sound wave to go back and the echo to come back. So I used to do this with my students previously. And we'd go 100 meters from a wall and we'd be able to time how long it takes for the sound to go to the wall and come back and measure it reasonably accurately. We used a slightly more complicated method which allowed us to be able to get accurate results. But in this example, they just did it to go there and back, and they only got 2 results. Okay, so deduce why the student thought it was necessary to make a 3rd measurement on data number 2. So this one said the first 2 results were different. Yeah, so basically in the second set of data, they timed it once, they got 0.44. They timed it again, they got 0.69. So they realized that one of them was incorrect. So either whoever was timing wasn't paying close attention or whatever. So they repeated it to see which one was the correct one. And this student doesn't get it right because he says it looks like the second data is an anomaly, but they're not asking that. Yeah. Why did the student realize that he needed to take a 3rd measurement? It's because the results were different. Yeah. They were too different. So they were unreliable. And that's why he took a 3rd one. And that's why you could work out by looking at 3 that the middle value was the anomaly one, or the anomalous one. Okay, so have a read of what the examiner's written here. The next bit is about percentage uncertainties. They want you to calculate the percentage uncertainty in the mean value. Yeah, and what you've got to do is work out half the range. Yeah, so the range was this. Yeah, and the half the range would then be 0.04. You divide it by the mean value, multiply by 100, and you'll get correctly 8 point something %. And then you can calculate the difference in the value between the speed on day 1 and day 2. Basically, the only difference between day 1 and day 2 was the temperature. So you can see that the difference in the 2 speeds, one was 340, according to the student, the other was 348. No units. I don't like to see no units. Okay, although the student has put the units there, I think you should put them here and here as well to get into good habits. Okay, so he's worked out the difference between the 2 speeds. Yeah, it then says the students state that the difference in the speed is due to the change in the temperature. Well, they want you to explain whether the results obtained are sufficient to be able to make that conclusion. Yeah, it says this response was awarded full marks. Yeah, in all parts that we just went through. Only 2 reliable time values were found, so insufficient data, they're saying, for each temperature. Only a slight increase in speed was found, or difference in speed was found, but the difference in speed values may be due to uncertainties in the average times. It could be due to uncertainties, so he could actually work it out because he knows his uncertainty was 8%. From part 1. So if you've worked out your uncertainty to be 8.5%, what you could do is work out the difference between 8 in that's in there and say, well, that could just be due to the 8.5%. So 8 out of 340 is less than 8%. So he's quite right. It could be due to the uncertainties in the times. There presumably are other ways you can answer that, and you have to look at the mark scheme to see what they accept. Okay. 14 part C is about, I think it's about standing wave. Yeah, so in part C, what they're doing now, they're changing the method of working out the speed of sound. What they're doing is they're using a loudspeaker, a microphone, and a board to bounce the sound off, and they're using a loudspeaker and a sound meter to set up a standing wave. And from the standing wave, they want you to be able to do that. Now, I think this is a required practical for AQA. So I think this maybe the idea came from the AQA, and Edexcel have taken the idea, okay? Because the normal method for Edexcel is to use an oscilloscope to work out when the waves are out of phase. But this is a clever method, and I think it's a good one for Edexcel to include in their specification. So basically, they've given you a point where the intensity at B is a node. So this is a node because it's obviously the sound wave is reflecting off the hard surface, coming back and creating a pattern of nodes and antinodes. And both at point A and point B, you've got nodes, okay? But they're of different intensity, and they want you to explain why both these nodes are not the same intensity. Well, one is closer to the loudspeaker, yeah? The microphone is closer to the loudspeaker. So the student said, because the microphone is further away from the speaker at B, they mean. So the sound waves would have lost more energy by the time they reach B compared to A. Hence, the less intense the sound will be at B. Okay? Now, did they get the 3 marks? I doubt it. This is a 1 mark answer. Okay? But they got the idea that as you go further, the intensity decreases according to the power of the source divided by the area that is spread over, which will be an inverse square law, because the area will be the area of the sphere that it is creating as it's radiating outwards. So this answer got 1 mark out of 3, whereas this answer gets 2 marks, I think. And they're saying that not many people got 3 marks. So both A and B are points of minimum intensity, or nodes, good, clear English, where the waves meet out of phase or in antiphase. As the waves travel further away from the source, which is closer to A, wave energy decreases, inverse square law, yeah? So, and since point B is further away from the loudspeaker than at A, it has a lower intensity at B. I'm not sure they got the 3rd point on the marking scheme, because I think the 3rd point on the marking scheme for whichever question this is, 14, you've got to say that at B, they have similar distances from the, well, we're assuming that they do because we haven't got all the data. So this is not quite enough to get the 3rd mark. So I think this one, that's why it scores 2 marks. For the 3rd one, at B, the reflected sound wave and the original are about the same distance. So therefore, they will be roughly the same amplitude. Therefore, they will cancel more effectively than the 1A, which is closer to the original sound and further from the echo. So the echo reflected sound wave will not be as intense as the original. Okay? Hope that makes sense. In the final part of this question, they've wanted you to work out the speed of sound by looking at the distance between the nodes and work out that the wavelength is 0.16 meters. Now, I'm not sure that this student knew why the wavelength was 0.16 meters, because it looks like he's put 0.08 first, which is the distance between the nodes in the question. Yeah? The distance between nodes is 0.08, and then he's doubled it, maybe because he knew the speed of sound should be 320 meters per second. So I would have given this student 2 marks, not 3, but the examiner has given him 3 marks. I'm not convinced that the student knows why. I think the student has doubled it so that he gets what he knows to be the correct speed of sound in air. So it says the lambda is a distance between 2 maxima. Well, that's not correct. So I think the examiner's wrong here, and this should only be 2 marks, okay? But I can't correct the examiner. But what you should have done is to say that the wavelength is double the distance between the maxima. So I think the examiner's mistake is by not penalizing the student here. Yeah? Lambda equals 2L. Yeah, so remember, if you got a node, antinode, node, this length, the lambda will be equal to 2L. And this student's got it wrong, and the examiner's given 3 marks. And they put this in the examiner's report. So even examiners don't get their physics right all the time. All right, so that, oh, by the way, they're giving you the frequency in the question. Okay? In fact, this is the only difficult part of the question, and the examiners let them get away with it. Not impressed. Question 15. So this question 15 is then a 6 marker, and it's to do with discussing the photon model. Yeah. And why the wave model is incorrect. Now, I'm not going to go through this one. I'm going to let you stop the video and read through it and see if you can look at the mark scheme, which you can find online, and see how many marks you think this deserves. And you can stop the video when you want to. Let me just shrink the size if I can. Will I be able to? No, it doesn't let me shrink the size. So you can stop the video and read through it if you can decipher what they've written, especially in this bottom section here, and see if they get the 6 marks. According to the examiner, this student got a total of 5 marks, and they've explained why here. Okay? And then mark your own. So I think for this last question, it's better for you to use the examiner's report for sure. You can use it, but look at the mark scheme and learn how to do this, because this is a common 6-mark question. And if you know exactly, there's usually 4 marks for explaining why the photoelectric effect is a good model and why the wave model doesn't work. 2 marks for why the wave model doesn't work. And then get your linkages right. So this is another student's attempt. And this one only got 1 mark. So compare this to what you've written. See why they only got 1 mark. It's a really useful way of improving your own understanding. So for example, the student hasn't even mentioned the word photons. So key vocabulary would be my emphasis. So I always tell my students, you need depth, you need detail, you need clarity in 6 markers. There is no specific formula. And here's another question. Here's another student's work, 6 marker. And I think this one, if I remember correctly, having read the examiner's report before, is one that does get higher marks. No, 3 marks total. So they haven't got a 6-mark example. There you go. So see how you can get the 6 mark one, and then prepare for this for Wednesday, because this could be repeated in a future exam. Question 16, is this the last questions? Question, I think we've got 16, section B now. So this is inside a scanner, like an MRI scanner, and they want to use technology to make sure that the patient is in the right position. But initially, they're asking you just about resistance, because their method of ensuring they've got everything sorted is reliant on measuring resistance. Resistance can be measured directly using an ohm meter or using a voltmeter with an ammeter, so you already know that. Describe 2 benefits of using an ohm meter compared to using an ammeter and a voltmeter. Yeah, well, it's quicker, it's easier, but they're not accepting that as a mark because it's too general. So be careful, you know how to spell voltmeter. Yeah, that's a wattmeter. And ammeter, you would need to calculate the resistance yourself. Well, yeah, it does save you from calculating it. And an ohm meter doesn't require current like a voltmeter. Well, that's not true. So this won't be 2 marks. This gets 1 mark. Okay? An ohm meter actually has its own power supply in it. It's actually doing the calculation for you. It's measuring the current of its known power supply, and it's working out what the voltage, what the resistance is. So it's doing the calculation for you. Okay, have a look at the mark scheme. This student gets 0 because it's too vague. So look at why it's too vague. Okay, he just says it's more accurate. You're not going to get that, yeah, as a benefit. You can't say things which are general. You need to say things which are specific to show that you know some science. There's less room for error. These are just general statements, okay, thrown in there hoping to get a mark. Okay, this student gets both marks. So I'll let you read it and see what the examiner says. Okay. Question 16b, it then says, state and identify how the applied force changes the resistance of the wire. So this question is at the end because it links materials. By stressing a material, it increases the length. So you change the extension, delta length or delta x, whatever you want to call it. The length increases, and then the length increases the resistance, and that's why applying the force in terms of Young's modulus produces strain, and it's a strain gauge, and the strain increases the length of the resistance wire, which then allows you to measure the changes. Okay, so I'll let you read the question if you haven't done so already, and then look at why this answer scores both marks. Okay, I think this part of the question is reasonably straightforward, yeah? And this is a second attempt. This is a good 2-mark answer, so you can compare it to your own. Then they want you to use the formula that they've given you in the question paper, which is a little bit more confusing. They've given you a formula called GF. They've given you GF equals delta R, change in resistance, over R with strain in there. Okay? So we know delta R is 0.0001, delta R over R. So we know this value is simply that. And they've told us that this value is 2.0. So you can work out what this is and work out, obviously, it's equal to the change in length over the original length, which was actually given as W. You can look at the question. So once we know GF, because we know GF and we know the ratio of the percentage change of the resistance, then the only unknown is epsilon. Once you work it out, you can then put it into this equation and work out the only unknown, which is delta W. They want you to calculate a change in the width of the strain gauge, which from a resistance point of view is the length of the resistance material. Okay, so this student has done it correctly, yeah, and scores all 3 marks. So you can have a look at the examiner's values, but I think the wording is what's confusing in this question. So, and I think as you get to the end of questions, they like to make the English more difficult. So if you're thinking of doing physics, your English has to be very good as well to be able to explain things clearly, okay? Here's another case which also scores 3 marks, okay? Now the mathematical questions, students always have a good go at them. The problem is like the 6 markers where you got to explain things in clear English. So another one that gets 6 marks, 3 marks. Question 16, it says, explain the benefit of arranging the wire in a zigzag pattern. So basically, as you strain the material and it's in a zigzag pattern, each bit of the zigzag pattern gets an extension in length, which then has a bigger impact on the resistance, so it's easier to measure. It makes it more sensitive. Because remember, it's a strain gauge. So depending on how much increases the length, which then changes the resistance, which then allows you to work out how much strain there is, by having the zigzag pattern of the material that both has resistance and is creating the strain, you get a more sensitive material. So this is a good 2-mark answer. I'll let you read it because we're short of time. Okay? This answer is 0. So obviously a student doesn't understand what they're talking about, and you can have a look at it. Explain the benefit of analyzing the wire, and this one scores 1 mark. Yeah, it says the length is multiplied. So you're only making 1 point, so it only gets 1 mark. Have a look at the mark scheme as well, which you can find online. Question 17b, it's about roller coasters and the conversion of energy, and it's giving you a long passage to read, okay? So this is typical of the Edexcel linear. The last 2 questions, they want you to have a reading comprehension, and then they'll ask you questions to analyze about it. And you've got to grab the data from the information given in the section. So read what the examiner's report says about it, read the question, and then you can see this student's answer. This response gets 3 marks. Have they written out clearly? This is what they're given. This is what the student has written down, what they know. They've chosen the correct equation to use SUVAT-wise, and they've worked out the acceleration as 9.61 meters per second squared. So this, and then they've compared it to what the claim was. So it's nearly 9.81. Yeah. So that making a conclusion. Okay. So you're comparing these 2 values. It says, I think here, and that's part of the questioning technique at the end of this paper. Okay. And this the second part of this analysis, they want to look at a different type of roller coaster, if you like. It's a way of creating a force horizontally, if I remember correctly. So this time you've got to use SUVAT again, and this student's only got 1 mark for this 3-mark section. So why is that? Okay, and what did you do? Okay, they're going to give us a correct answer, presumably. This response scores 3 marks, and you can look at it. And again, I don't think it's as good as the first answer. They've got the final velocity, they've got the time, and you need to change this into meters per second, and you'll find the acceleration is going to be 18. which is within the safety limit that they were talking about. Okay, so it meets the roller coaster standards because you don't want the acceleration to be greater than 6G. That's what that's written there. So have a look at this and see if it helps you to go through your own paper. They then give you a question about comparing making a roller coaster, discuss how the use of steel rather than wood has made the construction of roller coasters faster and taller, that they've made it possible. And it's basically giving you the stress-strain graphs for steel and wood. And this one gets 3 marks out of 5. So look at the mark scheme and see where they've lost the marks, okay, against the mark scheme. And let's see if they've given us a 6 mark, a 5 mark one. This is a strong 4 mark answer, almost 5. The answer is you need 5 points. So try to work out where they've lost the 1 mark. Read through it, compare it to your own answer, and learn from someone else's way of writing. Okay, so here they're giving you a paper summary, so you can read through it. It's taken longer than I expected, yeah, and they're the grade boundaries for the year, okay? So I hope you found it useful. If you did, just let me know in the comments whether you want more videos like this. If I do it again, I'll probably do it in shorter parts. So do several parts and to go through it with a little bit more explanation. Ideally, I would link it with doing the paper as well. But because the exam's on Wednesday, I won't have time to do model answers for all the different papers. And you'll find some of the papers I've done already in the playlist if you have a look for them on the homepage. Okay, well, thanks for watching. Don't forget to pass on your comments so I can know if you want what kind of videos you want in the future. Bye for now.